the exact stuff that's going to be on it in order too?
No. No. So, I think I already explained this, but let me say it again. So you're all going to be paying attention now. Okay? Your exam, and you got the exam schedule. I don't know what day you take it, either Wednesday or Thursday. And it's a regular class period, so it'll be just like today. Regular class period. So the exam will be like the length of a regular test. I haven't written it yet, but my guess it's going to be a couple of pages front and back. Okay, that's all you can do in 55 minutes. The problems on the exam, obviously there's more than that on these review sheets. So the problems on the exam will come from the review sheet. But not all of these are going to be on the exam you take, okay? So some of you might have a problem like 1A, but others of you won't. Just, if you know what's on here, you're going to be all set, okay? All right. What?
This work.
What? What?
Do we still have to go to the class if we have an A in it, or if we're not taking an exam in it?
You do not have to come on exam day, but you have to come on the review days.
Okay.
Okay. So, everybody clear on that? So the problems will not be in this exact order. Okay? They'll be mixed around so I can fit them on the page or whatever. All right? But this is what we need to know. So this is what we need to practice. So here we go. One of them's called nothing and one of them's called number 2. So this is the one that doesn't have anything on it. So number 1. It's not number 2. All right, so it starts off with an exponent and we're simplifying, and you should be doing it. I deliberately spaced this out so you had room to work. So hopefully you are busily working away on the problem. What would you suggest we do to get started? It may not be what everybody else wants to do. It's okay. There's lots of ways to start. Rory?
Do reciprocal.
So Rory says, I have a negative exponent here on this whole fraction. I know that's going to flip it over. Now, here's where some of you tend to get confused. If you are doing this negative right here, if you say, I'm going to flip over the whole shebang, then you flip over the whole shebang. You make no changes in it. So this is going to be 5xy to the negative 4th, and this is going to be 3x negative 2y7, and now it's going to be squared. Now again, no one says this is how you have to start, but that's okay. That's a way to start. That is something that needs to be done. All right, so what would you think we might do next if we started that way? Grace? So she says inside here I have some negatives, so I might change some of those. So I get my 5x is okay, and my 3 is okay, but this guy's going to come down, and this guy's going to go up, and that guy's going to stay down like that, Grace? Okay, that has to be done. Those negatives have to be dealt with, so she did it. All right, now what? Simplify. So inside the parentheses, I have an x times an x squared. Won't that be x cubed? And then on the bottom, I have a y 4th times y to the 7th. That'll be y to the 11th. And now what? Square everything, including the 5 and the 3. Now, let me say one more time. You should end up with this answer, but you do not have to take this path to get there. Personally, I'll clean this up first. That's where I always start, but it doesn't matter. It does not matter. So start wherever you want to, but ultimately, you should end up there. All right, the next one, simplify. All right. What do you think we ought to do here with this simplify problem? Absolutely, absolutely. So cosine is cosine, so I'm not changing that one. What's tangent? Sine over cosine. I'm very impressed. Good for you. You need to remember that. That's something you're going to need in your math future, so I'm glad you remember it. What's secant? 1 over cosine, and it'll be squared because it's secant squared, and then sine over 1. As Grace said, we don't change sines and cosines. They're like the base units. We change everything else. All right, now, it's all multiplication, so we can start canceling. That's going to cancel with that. That's it. So it looks like I have sine squared over cosine squared. If I multiply, and what's sine squared over cosine squared? Sine squared plus cosine squared is 1. What is sine squared over cosine squared? Tangent squared. Yeah, that's tangent squared. Good, good, good. All right, now the next one. This one's a little bit harder. All right, anybody notice anything about that problem? What? Okay, I mean, yeah, there's a lot of stuff. This is, it's factorable. I heard somebody say it. It's factorable. That's the same as having x squared minus 3x minus 4, except we have signs instead of x's. So that factors how? Perfect. Absolutely perfect. That's a little quadratic right there, and it factors. Now, usually the purpose of factoring is so that I can cancel. Obviously, that is not going to cancel with this, but this is the tricky part. You have to remember, cosine squared can be rewritten. Do you remember how? 1 minus sine squared. And that's because of the thing somebody said a minute ago. Sine squared plus cosine squared is 1. So 1 minus sine squared is the same as cosine squared. And again, the reason that should pop into your head is this is a simplified problem. The directions say simplify. Simplifying a lot of times means canceling things out or collecting like terms. These are not like. So we think, oh, we can change that. Once we change it, what can we do to it? What can we do to that? Difference of squares. That's the beauty of it. It's the difference of squares, so it's always going to factor. So when I factor it, how will it factor? Watch it, you're backwards. It's actually 1 plus sign and 1 minus sign, right? And it doesn't really matter for this one, but it matters for this one. So you want to make sure it's 1 minus sine squared. Now you can cancel. And so our answer is sine minus 4 over 1 minus sine. Now remember, the purpose of a cumulative review like this is to tell you what you need to study. So if you struggle a little bit with that, you go back to your notes. I forget what section that is. It's like 5.1 or 5.2. Go back to your notes, and there you go. Lots of practice problems you can review. All right, the exam will be in 2 parts. Part calculator, part no calculator. Now, so far, I've had no need for a calculator at all. Those could easily be no calculator problems. This next section is specifically no calculator. So you will need to be able to find the exact values of the cosine of 120, the tangent of pi, and the cosecant of 5 pi over 3. Now, Michael, not those exact problems, but problems just like it. All right, so you remember what to do? Let's start with the cosine of 120. What do? I would draw a triangle, that's right, I would draw a picture. And when I draw my picture, I have to remember some basics about trigonometry. I start here, go this way, so there's 120 right there. That makes the reference angle 60, right? And across from the 60 is root 3. And what I always caution you about, don't forget your negatives if you're not in quadrant 1. Okay, now what do I know about cosine? So TOA, adjacent over hypotenuse, so negative 1/2. Negative 1/2 adjacent over hypotenuse. You can also think about it as x over r. That's another definition of the cosine. All right, tangent pi. What about that one? What's pi? That's the radian measure. That's the equivalent of what? 180 degrees. So this is the tangent of 180 degrees. What's special about 180? It's on the line. It's what we call quadrantal. So I don't draw a triangle, I draw a circle. A circle with a radius of 1. So x is negative 1, y is 0 at that point, which is 180, and r is 1. When I draw my own circle, I always make the radius 1. Now, tangent, so TOA, I know you know it's opposite over adjacent, but that isn't going to work because you don't have a triangle. So what's the other definition of tangent? Y over x, y over x. Try to remember tangent is slope. In fact, that's kind of the groundwork of differential calculus. Tangent is slope, so y over x, y over x. So if I put y over x, I get 0 over negative 1, which is 0. These are the ones sometimes that turn out undefined. This one didn't, but remember getting undefined sometimes? That's when the 0 is in the denominator. All right, cosecant 5 pi over 3. What's 5 pi over 3? Well, you just told me pi was 180. Divided by 3 would be 180 divided by 3 would be 60, and 60 times 5 is 300. So we're finding the cosecant of 300. So we'll do just what we did up there. We'll draw 300, starting here, all the way around. If that's 300, what's that? Another 60. So this is root 3, that's 1, that's 2, that's negative. Cosecant is the reciprocal of sine. So sine is opposite over hypotenuse, so this will be hypotenuse over opposite. So hypotenuse over opposite is 2 over negative root 3, or negative 2 root 3 over 3 if you rationalize it.
So in the final, are we going to get that answer? We're going to simplify it, right?
You need to simplify it, yeah. You need to simplify everything. Now, the nice thing about the exam not being multiple choice is you're going to get partial credit, obviously. If you stopped here, you're going to get almost full credit because that's the right answer. Something that wasn't covered on this one may be covered in the second one, but there's no 45, 45, 90s in here. And you need to remember that in a 45, 45, 90, the sides are 1, 1, root 2. Okay, so make sure you review that too, in case that shows up in one of these problems. All right, take a look at this equation. Let's finish this up. Is this equation growth or decay? Decay, because the base of the exponent, which is 0.73, is less than 1. Now, the pieces are all coming together, kids, because if I said to you, what's the limit of that? You would say 0. So what's happening? It's shrinking, 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 right? See how it's decay and the limit's 0? All right, what is the percent growth or decay? Be careful. 0.27, 27% decay. Remember, your growth and your decay are how much more than 1 you are or how much less than 1 you are. And then what's the initial value? 300, right, 300. Okay, so let's get cleaned up. Men, we are finished for today. I will see you next time. I guess virtually on Monday.
Looks like you've been down there.
All right.
Looks like I'm leading the pack.
Bye-bye.
Yeah, for the whole semester.
What?
I'm leaving in less than 2 weeks.
What are you talking about, George? Blabbing on that.
Our little competition over in the front right corner. Do you agree Declan's been falling to the back of the pack?
What is with him? And now I understand. He emailed me and he said, since I missed class, this was like a couple hours ago. Since I missed class, and I take the class in the office hours, and I just emailed back and said, give me that class, but I missed one.
Yeah, that doesn't make sense.
All right, people, get your desk cleaned off. $77 is the lowest seat. So where are you?
That question, I did get.
All right, you hand us out. Where's this all yours, right?
Are you getting a good example?
Yep, our meeting desks are coming to an end. You're almost done. You're almost done. And you know what I just noticed today? This class is going to be your last, like, actual class of your high school career. Not exam, but your actual, like, class. Is our last exam? Are we the last exam? Well, how about that? We're just awesome.